Take a breath, feel the weight of your body, and look at your hands. They feel solid, permanent, and undeniably real. But if we pull back the curtain on the deepest math in modern physics, that solidity vanishes. Modern physics suggests our three-dimensional world, with all its depth, its oceans, and its stars, may be a projection emanating from a flat, two-dimensional screen of quantum information painted on the absolute edge of the cosmos. This framework, known as the Holographic Principle, describes a universe where the space around us functions as a computational output. If the mathematics hold, the 3D reality we perceive is a macro-level display of a 2D code. The road to this discovery began in 1972 with a crisis over cosmic garbage. Physicist Jacob Bekenstein realized that throwing a hot cup of tea into a black hole seemingly violates the second law of thermodynamics. By hiding the chaotic states of the tea inside a hole, you effectively delete entropy from the visible universe. To save the laws of physics, Bekenstein calculated the maximum information a black hole could hold. He found the internal volume vanished from the ledger. Instead, capacity depends exclusively on the two-dimensional surface area. When a star collapses, its three-dimensional information is encoded flat across this horizon's boundary. In 1974, Stephen Hawking showed that black holes are not perfectly sealed. Quantum fluctuations at the horizon cause them to leak heat, Hawking radiation, meaning black holes eventually evaporate, leaving behind nothing but a featureless cloud of heat. Hawking's math showed that this escaping radiation is completely random noise. It carries no record of the objects that formed the black hole. When the evaporation is complete, that original data appears to be permanently erased from the cosmos. If the universe can lose its record of the past, the fundamental laws of quantum mechanics fail. Without that data, we lose the ability to trace subatomic states back to their origin, making the future of any system mathematically unpredictable. Physicist Leonard Susskind viewed this loss of information as an existential threat to the meaning of science. He spent years searching for a location, a place where the data could survive the reach of a black hole. He used a thought experiment involving two astronauts, Alice, who hovers safely outside a black hole, and Bob, who falls toward the event horizon. Susskind proposed black hole complementarity. To Alice, Bob's data is scorched onto the two-dimensional surface of the horizon. To Bob, reality remains a smooth, three-dimensional volume as he passes inside. This preserves the logic of quantum mechanics, because the information is never actually in two places at once. It is a single entity described in two different ways. Gerard Tooft realized this logic applied to any region of space that can be enclosed by an imaginary boundary. If the maximum data a room can hold is limited by its surface area rather than its depth, then the entire three-dimensional universe functions as a holographic display for information occurring on a distant two-dimensional edge. In 1997, Juan Maldacena provided the mathematical proof for this transition from black holes to the wider cosmos. Maldacena's ADS-CFT duality demonstrated that every gravitational event inside a 3D space has an identical calculation occurring on its 2D boundary. In this framework, our 3D world is mathematically interchangeable with a flat quantum code. Measuring the resolution of this projection requires zooming down to the Planck length, the absolute smallest unit of distance allowed by physics. At this scale, the smooth fabric of spacetime disappears. We find holographic noise, a choppy, vibrating mosaic of digitized information. This limit suggests the universe runs on a fixed bitrate. Within this model, gravity and the flow of time emerge as macro-level phenomena, byproducts of the collective interactions of quantum bits on a distant screen. Testing this theory requires looking back at the oldest light in existence to see if the universe started as a flat field of data. This is the cosmic microwave background. When astrophysicists mapped its temperature fluctuations, they found that the patterns match a 2D holographic model just as accurately as they match our standard models of 3D space. This evidence supports the concept of it from qubit, where the physical fabric of spacetime is woven together by quantum entanglement. If you systematically sever the entanglement between two regions of space, the distance between them stretches until the local spacetime fabric simply vanishes. Spacetime functions as a complex geometry, meticulously stitched together by an unseen quantum network at the universe's edge. Materialist philosophy suggests we are temporary biological entities, made of matter, destined to dissolve into the soil. The holographic principle describes the human body as a three-dimensional avatar, a puppet moving through a localized, projected stage. The architectural ledger of your consciousness and memories exists as a permanent quantum script written on the cosmic boundary. You exist as the calculation itself, the light of the hologram, looking back at its own code.